Hey guys, welcome to Science. We're doing our recording today by video, and we are going to talk about topographic maps because that is what your lab is about. Um, Topographic maps, you're probably thinking, why? The topographic maps are very helpful in your world. They can show us different elevations. So when you're hiking, maybe if you want to take a trip, maybe you want to do some building. Topographic maps can be very helpful in that way. And I want you guys to be able to interpret these. Let's take a look at a couple of examples. These are all topographic maps on the screen. Some topographic maps can get very complicated and very intricate. Some are very simple, and there are others that are somewhere in between. Okay, these are all topographic maps, all equally awesome. All right. We're going to take a look at a very simple topographic map to get us started. On the screen, you can see this looks like a bunch of circles. Okay, and I get that, it does. It looks like circles. But these circles all represent something. They all represent equal elevations. Okay, equal elevations. And that is important to know because everywhere from this line, everywhere on this line, it represents an elevation. And this happens to be 0. And just so you guys are aware, 0 is sea level. Okay, so that's our marker for sea level. And we're like where the land meets the sea, okay, at 0. So if I have a contour line with the lowest elevation of 0, then I probably have an island, okay? So I want you guys to know that. We have another contour line just above 0. That's 10 meters above sea level. So this is 10 meters elevation. And everywhere on this line is 10 meters of elevation. Now, as we move from this 0 meter line to the 10 meter line, we're going up in elevation. Okay, so we're traveling up in elevation. And when the lines are closer together, we get to 10 meters faster. When the lines are further apart, it takes us a longer time to get to 10 meters. I want you to think about this. When you're climbing a mountain, you're going to get to 100 meters faster than if you're climbing a gentle slope. So when the contour lines are further apart, these circular lines are called contour lines. When they're farther apart, it's a gentle slope. Okay? So this is a very gentle slope. When they're closer together, it's a steeper slope. And I'm going to show you a little bit more about that here. So when we have, if these were contour lines and they're further apart, then we have a nice easy climb if we're going hiking. If our contour lines are closer together, our climb just got a little more difficult because that's a much steeper hill here than we have over here. Okay. The difference between these two lines is our contour interval. Okay, so these are our contour lines, and these are markers, so they're contour interval lines. They're darkened, and the difference between them is our contour interval. So if we want to know the elevation change between these two lines, we would take the larger number, subtract the smaller number, and that would give us our contour interval. So the contour interval between this line and this line is 10 meters. It's kind of easy on this map. The contour interval then between each of the contour lines on this map would be 10 meters. So our interval will be 10 meters between each of these contour lines. So we could count by tens to figure out the elevation if we didn't know. So if we wanted to find the elevation at this line here, we would say, okay, this is 0, because we know we're starting at 0. 10, 20, 30, 40, 50, 60, 70 meters. Okay, so this would be 70 meters right here. All right, what a topographic map does, and we know a little bit about what we're looking at. I want to talk to you about what it does. It takes an elevation or a topography, which is the landscape, and it flattens it. So it's almost like it stamps it down and mushes it into paper, okay? So it takes it from a 3D view to a 1D view. And this is how it does this. So this right here is our topographic map. But if we were to be looking at the landscape, so we're standing outside looking at the landscape, this is what it would look like. And you can see these inner circles, they're very small, and those are your height, your highest elevations, okay? So we can see this one. If we expand this up, it would look like this. This would be our innermost circle right here on the map, right there. Let me show you how they do this, okay? Because this, going from this to this can be complicated, and I want you guys to see it. And what we're going to do is we're going to shrink this map just a little bit. We have this topographic map positioned on the screen, and I am going to add a profile graph. And a profile graph, if you look at it, it looks very much like something you would draw a bar graph on. You have these lines here, and we can make them a value of any kind. And we're going to make ours to correspond to this map here. All right. So we will make this bottom line 0 meters. Oh. Like that. And then we'll make the next one 10 meters because our graph counts by tens. And so we're going to count by tens. Works out pretty well. And I'm going to show you guys a little bit about how this works. So we have 10 meters, 20 meters, and so on. We can count up. And we'll make our last marker 50 meters. So I can show you a little bit about how this would go. So this would be 30, 40, and 50 would go here. All right. And when we're doing a profile, this is like the side view. Think about your profile. It's your side view. So we're going to take a side view look at the landscape. So instead of a person, we're going to be looking at the landscape. And in order to do that, what I do is we take, and we're going to draw vertical lines, okay? But first we have to choose a path. How are we going to hike across this landscape? And so we're just going to, pick a path, and then we're going to follow it in our profile. So we're going to decide where we're going to look at this landscape to see what it looks like. And we're going to go here. So that is our path. I want to make that a little bit thicker so you can see it a little better. Okay, and then what we're going to do is we're going to start dropping vertical lines along our path so we can see that side view. This outside contour line, this contour interval line, it is 0 meters. So we're going to go, our path intercepts it here. So we're going to go from here. We're going to drop down to 0 meters. Just a straight line. And then we're going to come to the next line. That's a 10-meter line. And we're going to find out where it intercepts our path, which is right here. And so we are going to drop a line from here down to the 10-meter line. So see, we have 10 meters. Come over here, and we come up here. That's 10 meters. And then we have our 20-meter line. So we're going to drop a line from 20 meters where it intercepts our topographic map. Follow that around. Boop, it intercepts right here. And we're going to drop this down to 20 meters. And then we'll do the same for 30. And you can see, if you look at this, you can see that we have started, if we connect the dots, the end dots, or the end points of our lines, you can see we have started to build a hill right here. We started to build a hill. So if we were walking this, we would be going uphill, and that's exactly what is happening because our contour lines are telling us the elevation is getting higher and higher as we go in towards the middle of our map. And so it builds this hill, and when you get up here to the 50-meter mark, which would be right over in here, then you would have come to the highest elevation that we'll cover in our path, and you would start to go down from there. So this is a profile. It's that side view of the landscape. So if you were to step back from the hill and just look at it as it sits across the horizon, or the backdrop of the land, you would see this profile. You would see a hill. And so that is a topographic map, and it is the topographic map profile.